Okay, so here's the next question for the problem of the day. That is simply this. Again, let's just write. Okay, so the next question is minimum number of operation to make elements and array distinct. Okay, so what this question is saying, that let's just understand the question. So what we have to do, like we will given in this array, okay, and we have to basically get the total like distinct element in the array. Okay, so we have to just remove elements, that is 3 elements from the beginning of the array. If the array has fewer than 3 elements, then we will remove all the remaining element. Okay, and we have to ensure that the elements in the array are distinct. Okay, we have to always ensure that the array is basically elements should be always distinct. Okay, so if you see first example, that is this, you can see the elements are not distinct. There is 3 are repeated. Okay, so first 3 we have to remove it. Okay, so we will remove first 3. Okay, simply if I just cross them, we will simply return, basically remove first 3. Okay, then we will see again. Okay, this, that is here also 3 is repeated again. Okay, then we will simply again remove last 3. This basically first again 3. Okay, then we will see now these 3 are remaining, these 3 are distinct, so no element is repeated. Okay, then we will simply say the number of operation, we have to just return the number of operation to basically make this array distinct. Okay, so we have removed 2 times, that is 3 and 3. Okay, so that's why output is 2. So basically we got the explanation of the question. Okay, so let's just take this same example. Okay, and we will see how we are going to approach this question. Okay, so let's just take it 1, 2, 3, 4, 2, 3, 3, 5, 7. Okay, so this is the example. Okay, we have chosen. Let's just understand how basically we are going to approach. So if you see this question, okay, we can use hash set. Okay, because hash set, you know that it always take the unique numbers. Okay, so what we are going to use for first, we are going to iterate. Okay, so let's just I'm gonna explain you the method. Okay, so we are going to iterate. Okay, and every time first, like we are starting from 0 index, we will first we will check from this, that is this one. This, if this one is present further, then we will simply say this is not a basically this is not distinct. Okay, so simply we will check for this one, and from where we will check, we will check from the hash set. Okay, so what we will do, we will create a hash set. Okay, simply we will create a hash set, and in that we will check from this one, that is from this to 1 to last. Okay, we will check if this one is present or not. Okay, how we will check? First we will basically insert this one in this hash set, then we will insert this 2. If this 2 equals to 1, then we will simply return basically false, that we have seen this. Okay, if we have not, then we will simply say that we can simply return true, and we can say this is unique. Okay, 1 is unique. So in this then the 2 will get in, then 3, then 4, then 2, then 3, then all will be get in. Okay, so whenever if 1 was there, then simply it will return false. So 1 is not there, so simply it will return true, and it will say that it is unique, 1 is unique. Then simply we will move I. Okay, basically how we will move I. Okay, we will move I 3 times. Okay, let's by 3 iteration. Okay, that is simply here. Okay, we will move I here, because we know that after this the total number 3 numbers are unique. Okay, so basically you can say unique. Okay, then simply move to I to here, this position. Then we will check for 4 also. Okay, then simply the 4 is also unique, then we will simply skip the next 3 element. Okay, then we can simply come here. Okay, so no, one thing more. Yes, okay, so simply we will come here. Then okay, Then when we will come here, then we will see the 3 is present in the okay. Then when this will check for this 3, then it will say this 3 is present in the this set. Okay, then it will simply return false, and we will not see these 3. Okay, so simply we have used two operations. It will simply say the operation are number of operation are 2. Okay, so there's a basically, if you think this is typical method, then there's a one more method, that is simply reverse traversal method. We will traverse from last. Let's just understand that also. Okay, so simply what we will do, we will traverse from last. Okay, we will simply traverse from last, and then we will move to the first element. Okay, so this is the initial the first approach that we told you. The time complexity is big of n square. That's okay. So because we are doing two times, that is first this operation, then for this. Okay, but for this the time complexity is big of n, because we will basically we don't need this. Okay, so simply what we'll do, we will need a array. Okay, this time that have fixed number, because if you see constraint, we can simply take a array size of 128. Okay, because constraint are low, you can simply say the numbers are 1 to 100 in the. Okay, so simply we can say we can take the constraint size 1 to 128, or you can simply choose to 1 to 100 also. Okay, simply let's just remove it. Okay, so simply we will choose a array size of boolean array size of 1 to 128. Okay, in which what we will do, we will check, that will simply take care of the scene elements. Okay, so simply what we'll do, we will check from the last if we have seen this. Okay, if this is present in that array size. Okay, if this is present, then simply it will return true, but it is not present, it is coming first time, then it will simply return give basically, if I just make the array, okay, that will simply be like this. Okay, at 7th position, okay, it will simply give true. Okay, that it has present. Okay, at 7th position it will give true. So simply you understand what we are doing, what I am saying. Then we will simply iterate this 5, and then for 5th position also it will say true, because we have not seen 5 yet. Then it will simply move on 3. Okay, then then it will simply say true on 3th position also. Okay, then it will move on again on 3. Then it will then if I just make it. Okay, so just assume that 3 is here. Okay, so it will simply make true because of this 3, that is this. Okay, then after coming for this, it will see that 3 is all present already. So what it will do, it will simply count the, it will simply say that these are the total that we have to remove. Okay, so it can simply say these are the unique element. Okay, to basically till from I that has come. Okay, from previous basically, or you can say from last to this I position, these are unique element, and these are the elements that are simply you can say these not unique. Okay, so simply it will simply what it will do, it will this divide this I by 3, because we have to remove 3 elements. Okay, if these are odd, then simply we know that if these are basically divided by 3, then we can simply remove this in pairs. Okay, so simply it will say that I is, that is simply 5, so simply it will divide 5 by 3. Okay, that is simply give that is 1. Okay, that's will simply give 1, and it will add 1 also. Okay, so simply that because that is 0 indexing, so the 5 by 3 plus 1, that is simply give, so the answer would be simply 2. So basically you understand why what we are doing, we are getting unique element from the last. Okay, and we are simply removing till I to the first position. Okay, so simply if the if there is no repeated element, I comes at last, then we simply return 0. Okay, because there is no duplicate element. So this time complexity is big of n, and space complexity is also big of n, because we are using this array. Okay, so that's the question. Okay, you can see I've written the code. Let me zoom it. Okay, so yeah, you can see I have chosen this scene size as 100. Okay, not 128. You can see the limit is 100. Okay, so that's why we have chosen 100. Okay, we don't need extras. Okay, then we have simply used the loop. Okay, so simply it will start from the last. Okay, then you can see simply we are checking if this is present, then simply we will I by 3 plus 1. Okay, if it is not present, then simply we will make it true. Okay, so simply you can submit it. So yeah, it beats 100%. You can see the time complexity that is big of n. Okay, and you can also see space complexity, that's also big of 1, because this is we are using this array, we can take it big of n. Okay, that's okay.